Graph the solution set of 3x plus 2 is less than or equal to 8, and then express it in interval notation. This inequality is different from the ones we've seen before, because here we have to isolate x first. We don't already have it in the form x is less than a number or x is greater than or equal to a number. We've got to get the x alone first, very similarly to how we had to get the x alone when we were solving equations. Now, we had several rules that we followed when we were solving equations. We were allowed to simplify either side by using the distributive property or combining like terms. We could add or subtract the same quantity to both sides of an equation. We could also multiply or divide both sides of an equation by the same non-zero number. And for the most part, these rules work exactly the same as equations for inequalities, but there is one important difference. When solving inequalities, we may follow the same steps as we did for solving equations, except we must flip the inequality sign if we multiply or divide by a negative number, or if we switch the two sides of the inequality. So again, the rules are the same with the exception that there are certain circumstances where we have to flip the inequality sign. So if we start off with a less than symbol and we multiply or divide by a negative number, or we switch the two sides of the inequality, it's going to flip and become greater than. Now, we're not actually going to have to flip the inequality in this particular problem. This is going to be something that comes up in later problems, but I wanted to give you these rules now so that you understand the rules. Let's focus on this inequality now. 3x plus 2 is less than or equal to 8. Just like when we were solving an equation and we wanted to get x alone, the same is true when we're solving an inequality. And we're going to follow the same steps. To get the x alone, we need to get rid of that 2, and we can do that by subtracting 2 from both sides. That leaves us with 3x on the left, and this is less than or equal to 6, because 8 minus 2 is 6. Now be careful, we don't flip the inequality sign here, because what we did was we subtracted. And there's no rule that says we have to flip the inequality sign when we're subtracting. It's only if we're multiplying or dividing by a negative number, or if we decide to switch the two sides of the inequality. So far there's nothing that we've done that's required flipping the inequality. And the last step in getting x alone, dividing by 3, also doesn't flip the inequality, because here we're dividing by a positive number. And the rules say that we only flip the sign when we divide by a negative number. So in this problem, there is no flipping of the sign. When we divide by 3, that gives us x on the left, and 6 divided by 3 is 2 on the right. So we end up with x is less than or equal to 2. And now that we've solved for x, we can graph the inequality and then write it in interval notation. So I'm going to do my number line. And then let's see, we have x is less than or equal to 2, means we're going to have a closed circle at 2, because it's allowed to be equal. And since we're looking at x being less than or equal to 2, that means we are going to shade to the left. So our graph looks something like this. And if we want to write this in interval notation, it's going to be parenthesis negative infinity, comma 2 bracket, because we go all the way towards negative infinity to the left, and on the right we stop at 2, and since 2 is a solution, we use a bracket there. And so we end up with negative infinity, comma 2 as our final answer. Please keep these steps in mind, this rule, for future problems, because we will pretty soon see situations where we do need to flip the negative sign. And that's one of the biggest things that students struggle with, understanding when we flip it and when we don't. So keep a particular eye out for that as you go through these problems.